Right. Good morning, Algebra 2 students, or good afternoon, depending on, I guess, when you're watching this video. Um, we're going to move on to the next section today, and that section is Lesson 1-5. And our objective for today is to be able to solve linear inequalities. So earlier, with section 1-3, we talked about simplifying expressions. Then in 1-4, we went to solving equations. And now we're going into inequalities and how you solve those and how you work with those. So the progression was expressions to equations to inequalities, and that's what we're going to look at today. So let's take a look. The way I'm gonna kind of work this today is this lesson's got a series of questions, and what I want you to do is start at number 1 and then work through as many as you can. Okay, and any that you're not sure of, and you just have no clue, you can just kind of skip over it for now, or just put down not sure or circle it or something, and then move on to the next one. If you can't do something right away, that's fine, because we're going to go over them anyway. But I want you to at least try them in advance. Okay, so let me go to the next slide. And those are the 6 questions that I want you to work on. Okay, so right now, at this moment, what I want you to do is pause the video and then go through and actually start working your way through these questions. So for number 1, see if you can solve that inequality. Then try number 2 and ask if you can graph that on a number line, and so on and so on. So pause the video and give it a chance and see how you do. Okay, and we'll talk again in a second. All right, welcome back, everybody. Hopefully you had a chance to kind of work through some of those, and we're going to start going over them. So if you take a look at problem number 1 here, we are solving, this is a basic inequality. You solve this pretty much the exact same way you would solve an equation, except for there's one extra thing that we'll talk about. Okay, so therefore, if I'm trying to get x by itself, I got to get that minus 4 out of there, so we're going to add 4 to the other side of the inequality. Those will cancel, and therefore we end up with 3x greater than or equal to 17 in this case. And then just like normally, we would divide both sides by 3, and you end up with x greater than or equal to 17 thirds. And there's your answer for that first one. Okay, you can leave it as 17 thirds. That's perfectly fine. If you want, you could change it into 5 2/3. That's perfectly fine. If you wanted to write as 5.6 repeating, that's fine. The only thing that I don't really want you to do is if you have to round any decimal, if you're going to go with a decimal, if it would be one that you would need to round, I'd rather you leave it as a fraction, and rather you leave it just as this 17 thirds. Okay, so you don't necessarily have to do anything. So one of the big differences between obviously between an equation and an inequality is we've got these inequality symbols. This symbol is a greater than or equal to symbol, and we'll talk more about that as we move through the lesson. Let's take a look at problem number 2. So question being, can I take that answer and graph it on a number line? So let's go through and let's actually draw our number line out. And what I want to do is I want you to put the important points on the number line. You don't have to label every single thing. You don't have to go -2, -3, -4, whatever. What I want you to do is there's a couple of points that are important. Number 1 is I always want you to put 0 on your number line, okay, someplace. And then the other point that I want you to put, or points, would be the ones that you came up with for your answers, okay? So in this case, 17 thirds we said is 5 2/3. And so I'm going to put that over here someplace and call that 17 thirds. That's what we're going to take a look at. And so now we're ready to go ahead and graph this, okay? When I graph this answer on a number line, this inequality symbol up here is I want all of the values, okay? X is all of the values greater than or equal to that value of 17 thirds. Because it has an equal to, I'm going to go ahead and put a dot right at the, in fact, let me go ahead and do this in a different color. I'm going to put a dot, a closed dot, right at 17 thirds. And then what I want to do is I want to shade where all of those answers would be. So where are the numbers greater than or equal to 17 thirds? They would be over this direction, all the ones that are greater than. And then I'm going to also shade the arrow. And the reason I'm shading the arrow is to signify that it would go on and on and on forever, that it doesn't stop. okay? And so that's what that number line would look like. And we'll talk more, like I said, about open circles versus closed circles, the different inequality symbols, all that kind of stuff. Okay? But that's where we're at so far. Let's go on to the next one. So notice it says in number 3, when graphing inequalities, what's the difference between seeing an open and closed dot? I told you we'd talk about it. Here it is. So an open dot means that it is not included in the answer. Okay? So in that scenario, that would be a strictly less than or strictly greater than symbol. And if we go through and we're talking about that, here's your greater than symbol. Here's your less than symbol. Okay? If it's strictly greater than a number or strictly less than a number, that means we are not including that number. Okay? A closed dot, like we had on this last problem, means that that number is included in your solution. It is included as part of the answer. So that would be when you have a less than or equal to or a greater than or equal to. Okay? Excuse me, I said that backwards. So this first one is a greater than or equal to. The second one is a less than or equal to. Okay? So closed dots means you include that value. Open dots means that you do not include that value in your answer. And so as we move on to the next one, now we're going to take a look at number 4. This is what is called a compound inequality, and I'll show you kind of a couple ways. We can solve this in 2 ways. Number 1 is if I just went through and let's say I got rid of this first part and I just kind of ignored it like it wasn't even there. I could write this inequality in 2 parts. So I could go through and say 2x minus 3 is less than 19. There's the first inequality. I could then take the second part, the less than 19, excuse me, and I could just write this inequality. I'm going to flip it around though. I could write it as 2x minus 3 is greater than 7. And now I could go through and I could solve those inequalities separately. So we start on the first one, add the 3 to the other side, those cancel, get 2x is less than 22, divide both sides by 2, and we find out that x is less than 11. Okay? So there's part of your answer. That's not your only answer because of the fact that we actually have 2 inequalities here. That's what makes it a compound one. Okay? If we solve for the other side, I would add the 3 over. We'd have 2x greater than 10. Divide both sides by 2, and I end up with x is greater than 10 in this case. Excuse me, x is greater than, get rid of that, x is greater than 5. Forgot to divide by 2. And there's the other part of it. Okay, so as you look at this answer, what I want are the numbers. As we take a look, you can always kind of substitute an x for the numbers. Okay, if you just take out the x or read it as the numbers greater than 5, but I also want the numbers that are less than 11. Okay, so this is kind of your whole solution. I want the numbers bigger than 5, less than 11. Okay, as we take a look at that. I'm going to go back just for a second. Okay, and therefore, if I now go ahead and graph this on my number line, I can go through. Again, I'm going to put 0 on here. Always going to put 0. And then I want the numbers that we just came up with. Okay, and make sure when you put something on a number line, don't just randomly throw them on there. At least put them approximately. Put them in order so that you don't have positives on the negative side, and I don't put 11 before I put 5. So at least organize it somewhat. So there's the numbers that I have. If we take a look, because I want the values of x strictly greater than 5, that means now, switch colors, I'm going to put an open circle at 5, and the numbers that are greater than that, I'm starting to shade, are over here. But then I also want the numbers less than 11. So I'm going to open circle at 11 because I'm not including that. And the numbers less than 11, turns out that it's everything between 5 and 11 with open circles on the end. Okay? So that's what your solution would look like. You've solved the inequality and then you've graphed the solution on a number line. Okay? And you would need to do both things in your homework. Make sure you read the directions because I believe they ask you for both parts, or there might be some problems where they only ask you for the inequalities but not the number line. Other times they might ask you for both. So just make sure you read the directions. The other method of solving this compound inequality is we could solve it all together as one. So let's say that I've got 7 less than 2x minus 3 less than 19. I could actually solve almost like two equations in one, meaning if I'm trying to get x by itself, I would add 3. And normally we would say we would add 3 to the other side of the equation or inequality. In this case, because I have 2 of them, I'm going to add 3 to all 3 spots at once. That means these cancel out. Here I get 10 less than 2x less than 22. And now to get x by itself, I would divide by 2, but I would have to divide everything by 2. Okay, so again, in all 3 spots. So you actually get 5 is less than x, those 2's cancel out, is less than 11. And there is the other version of your solution. And what you notice is, notice how the x is sandwiched in between the 5 and the 11, just like we had on the number line over here. Okay, so you're looking at that. That's another way of doing it. Personally, I think this way is easier, so if it makes sense to you, I would do it this way. Okay, if this doesn't make sense, then split that inequality into 2 parts and solve each part separately. Okay, whatever way works best for you is fine by me. So just a heads up on that. All right, let's take a look at number 5. It says, is x equals 2 a solution to the compound inequality found in question number 4? So if we go through, does x equal 2, if I come back to this problem, we can answer this pretty quickly because here is a graph of all of the solutions, everything between 5 and 11. Well, 2 would be over here someplace, and therefore it is not a solution to this, okay? So, we're going to say it's, I'm going to put no. It is not in the shaded region, shaded region on the number line. Okay, so that's one idea. And then our final question, which we have not talked about yet, but this is the one thing that's a little bit different than equations, is sometimes when you're solving inequalities, you have to reverse the sign. What would have to happen when solving for you to reverse your inequality sign and explain incomplete sentences? So in that problem, if you remember back, and we'll see if you do or not, this might be one of the ones where you maybe remember doing it, but you couldn't quite remember the rules. And that is quite simply when you multiply or divide by a negative. By a negative number. Okay, so if you multiply both sides of an inequality by a negative number, or if you divide both sides by a negative number, okay, then you would end up having to reverse that inequality sign, and we'll talk about why in just a little bit. Okay, well, actually, let me just do it right now. Why not? So if we take a look, if I just pick 2 random numbers, let's say I take the number 2 and 5, okay, and I say which one's bigger? Well, 2 is less than 5, okay? But let's say I either divide both of those by a negative 1, or let's say I multiply both of those by a negative 1. Now that would change it to a negative 2 and a negative 5. And now if you think which one is bigger, now the negative 2 is actually the bigger number. So the reason you switch the inequality sign when you multiply or divide by a negative is because the rules switch when you go from positive to negative, okay? The bigger the number on the positive side, the bigger the value that you have. The bigger the number on the negative side actually means that you're more negative, and therefore that number becomes the lesser value, okay? So that's why you switch the inequality sign, Okay, so keep that in mind. Most of the times it'll happen when you're dividing by a negative in a problem. Okay, so that should hopefully get you up to speed on that. Here's just some other compound inequalities, and just in general, kind of what does the graphs look like. So if you take a look at this one, there's nothing to solve, but a compound inequality like the one we did previously is these are AND type of problems. Okay, these are AND type of inequalities, meaning you want values that are bigger than one number and at the same time less than another number. So these are always the ones that are going to be sandwiched in between two values. And so here I'm going to put an open circle at -2 because it's strictly, you want the number strictly greater than that. I'm going to put a closed dot at 1 because that's a less than or equal to. And then I'm going to go through and shade in between. Anytime you have an AND type of compound inequality, you will end up with shading in the middle of your number line, between two numbers. Okay, so that's just a heads up on that. Then if you take a look at an OR type of inequality, this one is actually written. It will actually have an OR in it. When you get to your problem, when you get to your solution, it'll all be there. And so here I want the values that are less than -2. So open circle, and here's the values less than -2. And I shade the arrow because it would keep going. Or I want the values that are greater than or equal to 1. So we put a closed dot at 1, and there's the values that are greater than or equal to 1. Okay? And so in this problem, if you select a number in this area, it would end up and plug it back into your original inequality, it would work. It would satisfy it and make it a true statement. Or if you plug in numbers here, those also would work. The only ones that wouldn't would be the ones in the middle. Okay? So AND type of inequalities, you always have the numbers shaded between. OR type of inequalities are always the two ends of the number line. Okay, so just kind of keep that in mind as you go through and you solve these problems. All right, let's take a look. So at this point, what I would like you to do when you take a look at this example is go through, pause the video, and actually give this a shot, and then we'll come back and see if you did it correctly. Okay, so take a second, pause the video, and see how things went. All right, welcome back. Here we are. If I'm going to solve for x, I'm going to just do this all in one step, meaning I need to get rid of that -8, so I'm going to add it over to the other side. And in this case, I'm going to add it into all three spots. Those cancel. I end up with a +6 here, less than or equal to 3x, less than or equal to 18. And now I can divide everything by 3. Okay. Notice I don't need to switch any inequality signs because I'm dividing by a positive number and not a negative. So we end up with 2 less than or equal to x, less than or equal to 6. There is your solution. There's the inequality solution. And then I always would like you to go through and take that solution and put it on a number line as well. Okay? I want you to graph your number line. So here is our value of 0. Here's our value of 2. There's our value of 6. And now we can start taking a look at what would we end up with. Since both of these inequality symbols are less than or equal to, I'm going to put closed dots at each part. And then I'm going to go through and actually shade the values in between. This is one of your AND type of inequalities. So I'm going to shade the number line in between. And that's what you would look like. So any number between 2 and 6 would satisfy this original inequality, and 2 and 6 would also work. Okay? 2 is included in our solution, and so is 6. So there's our next values there. Okay? Hopefully you did all right on that one. Let's check and see on the next one. Again, what I'd like you to do, go through, pause the video, take a second, try this one, and then go through and we'll see if you got it right. All right, welcome back. Here we go. This is an OR type of inequality, so hopefully you already know that this is going to be, you're going to be shading one end or the other of the number line, and therefore if we're shading one end or the other, let's solve and find out what those values are that we're going to shade for. So we end up adding 3 here on this part, trying to get x by itself. You get 2x less than 8, and then from there we can divide both sides by 2, and we end up with x less than 4 in this case. No need to change the inequality sign because I didn't divide by a negative. Or, let's go through and solve the other one. We add 7. add 7, those cancel. We get 4x greater than 16, divide both sides by 4, and we find out that x is greater than 4. Again, no need to change the inequality sign because we're not dividing by a negative. So now if we put the number line down, here is 0, and if you notice, I'm going to put 4 on here. That's really the only one that's going on. And then notice it says I want the numbers all values that are less than 4. And then over here, I want all values that are greater than 4. So the only number that I'm not including, this is kind of a tricky one, is 4 in my solution. So I'm going to actually put an open circle at 4, shade all of the numbers that are less than 4, and the arrow keeps going. And then I'm going to also shade all of the numbers greater than 4. So the answer to this problem is actually kind of all real numbers except for 4. 4 is the only thing not included in our solution. All right, if we take a look, I've got one last example for you, and then we'll get into the homework. So this last one, I'm just going to kind of go through it quickly. It's a very quick solve. If you notice, there's a negative x in the middle. Hopefully right away, by the way, you notice this is an and type of inequality, so we're going to shade in the middle of the two. I'm going to divide everything by a negative 1 to make that x positive. But now, because I'm dividing by a negative, all of the signs are going to flip. So we get a positive 3. Now the inequality sign switches. Second inequality sign switches, and then it's a negative 2. So there's my actual solution. Now if we put it on the number line, let me put down 0. Negative 2 is over here, positive 3 is over there. And now if we take a look, notice there's no equal, it's not less than or equal to, it's not greater than or equal to. So we are going to put open circles at both of those points. And I want all of the values that are sandwiched between those two things. So if we go through, I can shade right down the middle. And we had said this is an and type of inequality. So I have all the numbers in between those two that will work out. So it fits with what we had talked about earlier. Solving inequalities, to kind of summarize, is pretty much the same idea as solving equations. The only real difference is you just got to be careful of the inequality sign flipping. And then the second part is just recognizing that when you solve an equation, you usually get one solution. We find out that x equals 2, for example, or 5, or whatever it is. In an inequality, you have multiple equations. You have, like in this problem that you're looking at, you've got all of the numbers between negative 2 and 3. So there's a lot more solutions when you're dealing with an inequality, and that's one of the reasons why we have to graph that. Okay? So the homework that I want you to do, or the practice to learn that I want you to work on then for Monday, is 1-5 worksheet. Work your way through that. Make sure you're showing your work, and come to class on Monday or Tuesday, and let me know if you have any questions on anything, and we will work from there. Okay? Bring any questions on the lesson. Bring any questions from the worksheet.